Hey guys, how you doing? This is Andre again. Happy New Year for all of you. And I want to shoot this video on why I broke my Spindle drive last December. So you remember I posted some videos on this machine running, and it was running pretty good. I was happy for what I was doing, and cutting really hard. Actually too hard, probably too hard. And the reason I say that is because I was using my my Spindle drive and my Spindle system the wrong way. This is the MK drive. A lot of people use them. You can find them online. There's not a lot of information on it, but a lot of people use them. And so I say, like, why a lot of people use them, and I broke mine. So, and one day I was just sitting here, not here, machine was sitting, I was working on a vehicle over there, and I come here, went to swap up, a piece of stock, and hit cycle start. It went to do a tool change, never got orientation done, and it throw me a message here on Mach 3. Orientation was not done after it timed it out on the tool change. So I went back there, opened my cabinet, and I have alarm number 7 on the screen over there. And I'll come here to the manual here on this drive, and it says alarm number 7, current detection abnormal, current detection, circuit breakdown, contact with the technician. So my only choice was to call Automation Technologies and talk to the guy over there and tell him what was going on. And he told me, like, I don't know how that happened. That's a really good product, which on the messaging before that, he told me it was a really good product, and I see a lot of people using it. And so that thing broke. I got a little bit pissed on breaking after 30 hours of work. It's not even much for almost $2,000, and now it's already over $2,000, and which is not much. It is for me and for this kind of machine too. And so I said, well, maybe I made a mistake on buying the wrong equipment, or the wrong electronics, or Spindle, going cheap maybe. And it wasn't that. It was totally my mistake. Why my mistake is I was doing I was running the Spindle on step and direction, right? Which a lot of people do, but not this kind of Spindle. Why is that? Is because now that I broke that one, I wanted to make sure what I'm doing is right. I thought it would just be right from the beginning. It's not like that. When you change settings on something like this, it could affect like it did to me. So what happened is I was running step and direction. So in order for you to run a step and direction, you have to use position and control mode. And in order for you to use the speed position and control mode at a really high speed, you have to change that limit. And what happened is, when I came here, when it first came in, and when I put this one on, there's already a new one there that they sent me over. When it first came in, it had 1,000 RPM setting on the max speed on positioning mode. So I changed that speed over to 8,000 RPM because I wanted to control the Spindle, the motor, at 8,000 RPM on positioning mode. So what happened there is I was treating that Spindle like if it would be an axis, and the acceleration on an axis on any of this machine. If you see it on a Spindle, comparing to an axis, and the axis will go back and forth really fast. So I was using that same acceleration, not only like it came from the factory, from 0 to 1,000 RPM. I was using all the settings that they came from the factory, from 0 to 1,000 RPM. When I changed the speed over there, all my settings they stay the same, but it will have to do the same from 0 to 8,000 RPM. So I was pushing it 8 times whatever it was designed for, to the point that I felt sometimes that I was really pushing it, because my lights, they will blink when the spindle would go up on acceleration, or deceleration, and or decelerate, or would stop. So I was really drawing a lot of power on the machine whenever the spindle was going up and down. So when this new one came in, and I started wondering how could it broke, if it's a good product, if everybody says it's good. And so I said, well, let me put it in, unplug all my inputs, and just start from scratch. And that's what I did. I just started testing it with the control here, and or the panel, whatever they call it, and the spindle would go up and down really nicely. My acceleration was not really hard, and I started wondering, what if they change it? What if they change the setting just because they were going to send it over to me? They didn't change the setting. I changed the settings. So the mistake I did is I changed that speed from instead of 0 to 1,000 RPM, I changed from 0 to 8,000 RPM. So I was really pushing that drive to move that spindle that fast. And Mac, the software don't care. It would push it. And if it does it, it does it. If it don't, it don't. Something is going to break. So that's what happened. Something broke. And so what I'm doing now, I'm controlling my spindle on analog from the UC300 control board. And the analog that I'm using is 0 to 10 volt. And man, it's a whole, it's night and day difference on acceleration and deceleration on it. When going to stop, it does good, and going up, it's just like, it ramps really nice. You don't see no blinking, nothing. It just go up and down really nice. So I broke the spindle drive on this. It wasn't a faulty part or nothing like that. I just pushed it because I was treating it like an axis. And so since I find out I broke it that way, and how nice it's running on speed control, because there's a few ways to control the spindle. This kind of spindle, when it's a servo like that, you have speed control, and you have positioning control, you have homing control. The homing control that I do is they call it on the book quasi stop, something like that, quasi stop, or which is the homing deal on it. And that's the one I use anytime I'm gonna do my orientation, so I can do my tool change. And so all of this way to control your motor, they get a wire, an input that you can use to switch over to that to that situation whenever you need it. And this came with an idea, and that's what I'm gonna put out there for you to see if you get any ideas on how to do this. We all know it's almost impossible to do rigid tapping on Mach 3, because Mach 3 cannot really do a nice closed loop. For some reason, I don't know, I'm not an expert. What I do, I just been learning the last few years, and I got a lot more to learn. I can't say why. So Mach 3 is not good on that, but Mach 3 can do a really good job on controlling an axis, just like like an axis, not like the spindle itself. So the idea that came up to me is, so when you're gonna do rigid tapping, on my case, I got a final control on a Sharp. It's a 2012 machine, and I did a few rigid tapping the other day. And when you're gonna do a rigid tap on Fanuc, and you post it over to Fanuc and load the code, you press cycle start, the machine will get into a mode that you're not even able to push the feed hole. At least my machine would not let me do feed hold when I'm rigid tapping. It don't matter what I do, I cannot hold. I cannot do a feed hold. I can do feed rate. I can turn my feed rate up and down. If I'm not mistaken, I think I can. I'm not sure, but I believe I can turn my feet up and down, but I cannot do my feet hold. Or it's all the way around. Maybe I can do the feet hold, but I cannot change my feet rate. I believe it's the feet rate. Yes, I believe it's the feet rate, not the feet hold. So anyway, what I'm saying with this is these machines like Fanuc, they switch the machine, they switch the spindle from a spindle, they turn it over to an axis. So in the moment that you push feed hold and you call a sub program, I don't remember now if it's a G28 or M28. I think it's an M28 or M98, something like that, whatever. When they call that sub program, or they just switching the machine over to a different mode, and that's what came up to my head now when I was doing the switching from a speed control. I mean, switching from positioning control to a speed control. So I got a few ways to control it. So I said, what if I want to really do rigid tapping on Mac? If I'm able to control, I'm really able to control my spindle just like it would be any axis. Because you know, when you're threading, let me go get a bolt. This is a 1/2" bolt. Sorry, this is a 3/8. This is a 3/8 by 16, and this is a 5/16 by 18. So the reason I bought those bolts is, I know a lot of you know what I'm talking about, but you know, there's also people that are over there that want to learn, and I was one of them, and I'm still one of them. I want to learn. So what happened is, when you turn your machine to an axis, when you turn your spindle to an axis, what you do is you want to make sure, in this case, this is a 3/8 by 16 bolt. You got 16 threads every 1 inch. So what happened is, if we want our spindle to do this threading on this bolt, we want to make sure our spindle is going to be turning 13 times, while our axis is only going to travel 1 inch. Our C axis is going to come down 1 inch. So if it's a 16 times, because it's a, sorry, this is a 3/8 by 16. So we need to turn our spindle 16 times in 1 inch length when our C axis is coming down. So we got to come 1, 2, 3, 4, 5, 6, 7, 16. By the time we're done with 16 turns on our spindle, our C axis have to be already traveling right at 1 inch. So if I'm able to control my spindle and know how many times my spindle is going to be turning, I should be able to tell my C axis how much is going to be coming down while my my spindle is turning. So there's have to be some kind of formula that we can probably do on an M28 code. And I'm not saying, probably a lot of people have done it, and this is not my idea by no means. This just came to my head, and I'm gonna put it out here, and I hope somebody can help me. I'm here to, you know, but that's just the idea. If we got a servo on our spindle and we are able to do positioning control, we should be able to do threading on Mach 3, because we are going to control our spindle like an axis, not like the spindle itself. So that's the idea that came out to me, and I'm gonna show you how I'm able to just switch from from one uh, from one mode to the other one, and it's really simple. I got a relay back there, and I can call an M code and just do it. I don't think I have time to do it now to show you how the relay works and the M code. I'm just gonna show you how I'm able to turn my spindle back and forth using any axis. And you can find the rest of the information on YouTube. There's a lot of videos over there how to use an output, and I think it's overlay or something on the outputs that you can use to use a step and direction when you want to do something like that. But I really recommend, not because these guys are paying me a penny. I'm losing money on this already because of my mistake, but I'm losing money on that. They are not paying me nothing. Actually, this drive was not this one, but the one in it, the new one that they sent me from China. It was gonna cost around $800, even though I just used it for 30 hours. And I'm not complaining on that, it was my mistake, but I'm saying it was $800 even though I only used it for 30 hours, and it was gonna cost me about $800. And I said that's not fair because I only used it that much, but you know, whatever we had to do. And then the guy over there, Automation Technology, said, no, we're gonna come to an agreement, and the agreement is you're gonna do half and we're gonna do the other half. And that was really nice. I work for public out here. I work on vehicles, and sometimes I gotta do that. Sometimes I gotta do that. Many times I have to do that because we get a lot of faulty parts. We get a lot of problems with the quality of the products out there and the quality of the spare parts that we get for vehicles. Sometimes they're not as good as we think they are, and so sometimes I have to just do it and can't charge nothing because it was just yesterday. And sometimes I can do 50% on whatever happened if it was the part, and sometimes I can get a few things here and there. But anyway, what I'm trying to say is it wasn't on them, but I still had to pay for it. I paid half of it, so you know what half of somewhere around $800 is. And so the drive came in, I put it in, and it works good. I tested, I did my research on the manual before I break it again, and so I came with that idea of controlling my spindle like it would be an axis. So right now what I did, I switched my RJ45 output from my spindle, from my step and direction of my spindle. I took it out because I'm using 0 to 10 volt. Now I'm using this spindle like analog for milling, but I want to use this for threading on a step and direction. So for milling, I'm using a speed control, and for threading, I'm gonna use positioning control, which is gonna be like an axis output. In this case right now, I'm gonna try to get you as close as I can here. I don't know. So I got my indicator here, and I got a holder with a wrench here, with an Allen wrench there, and so so I'm using my A axis to control my spindle. I don't know if I can get you closer. This is faster. That's full speed. Why is full speed? Because I only set Mach 3 on the A-axis about 100 inches a minute, and that's the full speed that it's doing right now. About 100 inches a minute, somewhere over there, I guess. And so I'm gonna do some testing on that. I'm probably gonna do a name code. I'm gonna try to move C-axis and spindle at a certain speed and RPM to see how it looks, you know, coming up and down, like if it would be threading. But just to try it out, just to see how it looks. I don't think I'm gonna be able to just come out with a formula or a way to do that. I know there's some people out there, because I did some research. Don't remember the company name now, but I believe there's somebody selling some kind of board or control system that it will it will take over when you're doing the threading on Mach 3, and I believe that's what they're doing. I believe that's the way they're doing it, and hopefully that's what that's what I can use. And I don't know if I can use theirs with the UC300 or Mac. I mean, I know it's Mac, but with the UC300, it's probably their board. But I'm gonna try to do something like that, or at least get some help from some people out there. I got this friend of mine. He's been so nice. His name is Thomas, and he's been helping me a lot. He helped me a lot with this machine. He helped me so much with the Cincinnati, and they both of them, they came out good. And I'm gonna ask him if he got any idea on that. Well, guys, this is it. I hope you get what happened to me, and don't do it. Do the right thing. Use the speed control mode if you're gonna use your spindle, and then use positioning control mode if you're gonna do rigid tapping. So there is a way to do it, and I don't know if I'm gonna be able to do it on Mach 3 and maybe on this machine, but I'm gonna try. I'm gonna spend some time on that. And then next video is gonna be on how to retrofit if you buy a machine like this the cheapest way. I want to make a video on that because I have made some probably huge mistakes, and I regret it now. And hopefully this will help you. Hopefully this will help you. You can get one of these, and there's some people like that, they got them, you know, fairly cheap for for what is, you know, getting a machine, or, you know, getting a CNC, and you can probably retrofit them and they work. I mean, this one works. So, well, guys, thank you again for watching. I hope you get good stuff from this, and tell me if you get good or bad. I need to learn from you, and I hope you learn something from me. Thank you. Like I said again, Happy New Year. See you again.